Hi and good day, madam. We are delighted to be here today to present our collective efforts on heart attack analysis and prediction data set using fuzzy logic. We have used Python programming language to conduct this project. I must emphasize that this presentation would not have been possible without the expert. Next will be the introduction. Fuzzy logic is a powerful tool that transforms human data and technology into mathematical models using rule bases, fuzzy function, extraction processes, and refinement procedures. By harnessing the capabilities of fuzzy logic, doctors can automate heart issue diagnostics, paving the way for improved medical assistance in the future. Therapy involves the treatment of physical, mental, or behavioral disorders with the goal of either treating or rehabilitating patients. Cardiovascular disease is a group of illnesses affecting the heart and blood vessels, primarily arteries and the veins. Parameters like age, high density lipid level, low density lipid level, total cholesterol, blood pressure, fasting blood sugar level, family history of heart disease and gender serve as a valuable indicators to predict the incidence of heart disease. By employing a fuzzy expert system for heart disease prediction, clinical decision support can be integrated to reduce medical errors, minimize undesirable outcomes, enhance patient safety and improve overall patient outcomes. Our project aims to analyze medical data to determine the risk of heart disease and facilitate early detection and intervention, thereby reducing disease-related fatalities. Heart attack is one of the Malaysia's leading causes of death in the last 2 decades. So, our team chose this data set as a measure of our investigation as an awareness to people about cardiac disease and to develop an automated heart issue diagnosis that helps to improve the future of the medical field. We collect the data set of the chosen topic from the Kaggle data set. Next will be the attribute information. There are 6 types of attribute that is directly or indirectly related to the cardiac disease, which is age. Age can be the significant factor in diagnosing certain medical condition. Next, blood pressure. Blood flowing through blood arteries pushes against their walls, creating blood pressures. Cholesterols. All of the body cells contain cholesterols, a waxy fatty-like substance. It is necessary for the creation of specific kinds of cell membranes, vitamin D and hormones. Next will be the blood sugar. The quantity of sugar, glucose, in the blood is referred to as blood sugar. Resting electrocardiography. A test called resting electrocardiography ECG or EKG measures a person's heart's electrical activity when they are at rest. Next will be the heart rate. The number of times your heart beats per minute when you are at rest is referred to as your resting rate. It is usually measured when you are peaceful and relaxed, as when you first wake up in the morning before engaging in any physical activities. The last attribute will be the risk. Risk will determine the average possible having heart disease. The range based on data collected from the data table.
Hello everyone, I'm Gayatri Armugam. I will explain the coding session on this presentation video based on fuzzy logic framework on our disease structure. So let me share the full coding to make it easier on explaining it in detail. For our project, we used Jupyter Notebook, which is popular web-based interactive coding environment, and utilized Python 3 with a IP kernel package for executing this coding. We import 4 required libraries, which is the first one is NUMPY, import as NP that used for numerical computation, skfuzzy, it's a library for fuzzy logic operation, and the third one is skfuzzy.membership, import as mf will provide the membership function types for fuzzy set, and the last one is matplot library dot pyplot as plt, which is used for plotting the membership function and output. The second one is variable installation. Several variables are installed. Each will be represent a specific input and output parameter. These variables are defined the range and step for different parameters such as age, blood pressure, cholesterol, blood sugar, resting electrocardiographic result, and well known as ECG, heart rate, and risk level. From age until heart rates, it will be defined as X known as input value, and Y will be the risk, will be the output value. This coding will prompt the user to input the value of different parameter required from the diagnosing the risk for coronary disease at the end of the calculation based on the variable that state. So user have to input their value here. The next coding is for the membership function. The membership function will define each input and output variable using skfuzzy library. This function defines the degree of membership for given input value in different linguistic terms. Example, for age, they got young, middle, and old. For blood pressure, they got low, normal, high, very high. For cholesterol, low, medium, and high. For blood pressure is very high, and the ECG they got 3 level, and for heart rate also 3 level. Following that, risk got 5 level. This coding will refer to the graphic for this framework because a matplot library figure with a multiple subplot and create to visualize the membership function for each variable. The membership function are plotted using a different color and lines to represent different linguistic terms such as R for red, G for green, and B for blue. And for line, we use size 2 to define the line. And for example, for the blood pressure, they got 4 level. For very high, we use Y for yellow. And when we go to risk, they got five different values: healthy, early, middle, high, and advanced. So we different it with a new two new colors, which is yellow and M for maroon. So now we can see the output graphic framework based on the input detail for each variable. So I will show it one by one. The first one is age, and the second one is blood pressure, cholesterol, blood sugar, ECG rate, heart rate, and the final one risk. All these variables are differentiate with each color and line that based on the graphic that we insert. Then the membership degree. On this step, it will calculate the membership degree for the input value that provided by the user. Fuzzy.interp underscore membership is a function from the skfuzzy to calculate the degree of the membership for each input value to the corresponding membership function. Next is the fuzzy rules. Fuzzy rules are defined using a fuzzy logic operator such as NPFMIN for minimum, NPFMAX for maximum, and NPFmin for complement to combine the membership degree of different input variables and determine the degree of membership for each linguistic terms of the output variable for the risk. So the output risk for each input value will be defined based on the fuzzy logic rule that we created. And this part will be explained later by my one of the team member in detail. Now let's move to code interaction that union set. This code will calculate the union set of each linguistic term of output variable risk level by combining the fuzzy output of rules using np.fmax maximum. Dash union set represent the overall degree of membership for each linguistic terms. So this will be communicate each other of the rules that meet on same level of risk value. Then again a graphical visualization coding which is another matplot library figure to create a visualization output risk level. The degree membership for each linguistic term is plotted as fill area under a curve, and the original membership function are each linguistic term also plotted at dashed line. So here the output of risk level that differentiate with different color and dotted line that we implement on graphic coding that give a clear visual on output of the risk. And the last one is we implement to detect the risk of coronary heart disease diagnosis. Finally, the overall risk of coronary heart disease diagnosis is determined by finding the maximum degree of the membership among the linguistic term that's shown here. This value is represent the final diagnosis risk level based on the user input level at the beginning. And here the graphical visualization coding again to display the centroid defalsification of coronary heart diagnosis diagram that's showing here. So from this diagram, we can clearly see that the user risk based on the input value that they insert from the variable that we set. So the overall code provide allow the diagnosis of coronary heart disease risk based on the input parameter by the user and display the result through the graphical visualization. So that's all from me. Thanks for listening.
On to the second slide. So in this slide, I'm going to explain about the rules we actually implement in the our project. So I taking some of the example to explain. Okay, we are going for the first rule. The first rule is if blood pressure is low and the cholesterol is a low and the ECG is a normal and heart rate is normal, then it is a healthy stage. So so that means blood pressure is a low means we are giving the range of 0 to 110. The cholesterol is a low, the range is 0 to 200, and ECG is a normal state, so the range is 61 to 100, and the heart rate is a normal, so the range is 91 to 150. Then the risk will be healthy stage. The healthy stage range is risk range is 0 to 15. So we go for the second example of the rule 14. If age is middle and the blood pressure is high and cholesterol is medium and the heart rate is high, then risk is a high stage. So the age is middle, so the range will be 41 to 60, and the blood pressure is high, the range will be 151 to 190, and the cholesterol is medium, the range is 201 to 440, and the heart rate is high, so it will be a range 151 to 210. So the risk stage is high, the range will be 36 to 45. Next is a last example, rule 17. If the age is a whole and the blood pressure is very high, then the risk in middle stage. The age is a whole, so the range will be 61 to 80, and the blood pressure is very high, the range is for the very high is 151 to 190. Then the risk will be the middle stage. The middle stage risk range is 26 to 35. So these are the rules, some of the rules we imply in the projects. That's all. The last part of the project presentation, which is a conclusion. The prevalence of heart disease is on the rise, emphasizing the importance of the early diagnosis, risk assessment, and timely intervention. Similar to any other medical condition, identifying and addressing heart disease at an early stage is crucial. Technological advancement, particularly the integration of physiologic system in healthcare, plays a pivotal role in achieving early detection and accurate diagnosis. In this study, a physiologic method was developed to assess the risk of the heart disease. The system incorporates 24 rules bases and is structured as a multi-input and single output MISO system utilizing 6 input parameters including age, blood pressure, cholesterol level, blood sugar, resting, ECG data, and heart rate. By applying appropriate procedures to user data provided, the system employs a risk extraction engine and center of gravity prices to determine the risk of heart disease, while acknowledging that heart disease risk prediction system is not infallible and may not provide a 100% accurate prediction for a vast amount of data. There is a room for improvement. Enhancement can be made by incorporating additional relevant parameters, thereby making the system more efficient and suitable for assisting individuals in predicting their risk of developing heart disease in Malaysia. By expanding the range of the parameters considered, the predictive capability of the system can be further refined, leading to the more reliable risk assessments. By leveraging the benefits of the physiology system in healthcare, particularly in the context of the heart disease prediction, medical practitioners and individual can be greatly. The application of the physiologic techniques not only automated its diagnostic process to also provided valuable insights of medical professionals to deliver appropriate and timely interventions. Furthermore, empowering individuals with the ability to predict their risk of developing heart disease can be motivated proactive measures such as lifestyle modifications and early medical interventions, ultimately contributing to the improved cardiovascular health outcomes. That's all from me. Thank you.